Okay, example 2, most general antiderivative of this. Now notice, got a couple things going on here. First thing is I got a radical. And just like derivative world, I don't want to differentiate radicals, I don't want to anti-differentiate radicals. So power structures are better than radical structures. So f of x equals, and I'm going to call this again f prime. All right, so the 7th root of x squared is x to the 2/7 power. Then we make a fractional power, you take the power divided by the root, and that's this piece. Also, I've got 5 over x squared. There's no over x in our derivative formulas, our antiderivative formulas, right? There's no like something over x. Nope, don't have that. So we can't have that structure either. So if I have a fraction structure like this, I want to rewrite it as a negative power structure. 5x to the negative 2. Then I got this friendly little negative 2x to the negative half, which is behaving itself really, because even though it doesn't look very friendly, at least it's got an x to a power structure. The only power that we cannot anti-differentiate at this time is going to be negative first power. Okay, it does have an antiderivative. It's not very difficult either, but it's just not dealt with in this area. So you won't see any negative 1 powers happening. If you do, you can get an answer with a negative 1 power, but you won't see a problem with a negative 1 power. If you do, that just means somewhere you messed up because you created that structure yourself. So be careful of that. Negative 1 power shouldn't happen. Anything but negative 1 is doable, so all these are x's to powers that aren't negative 1, so we're ready to go. So if I want to go to f of x, it's going to be the antiderivative of x to the 2/7. So I'm going to add 1 to 2/7, which gives me 9/7. And again, mentally I'm thinking divided by 9/7, that's the same as times 7/9. All right, then I'm going to have plus 5x. Now, negative powers in particular, you got to remember you're adding 1, but you're going to be adding 1 algebraically, right? So add 1 to a negative, you're actually going to subtract. That gives me a negative 1. Again, we're allowed to get negative 1s in our answer. That's fine. Negative 2 plus 1 is negative 1. Divide by negative 1. Whatever the new power is what you divide by. Minus, okay, and then I got 2. All right, x, negative 1/2 plus 1 is going to be positive 1/2. Divided by 1/2 is the same as times 2 over 1. Again, this one had 2 fractional powers in it, right? So again, we had to consider the possibility of division by a fraction, multiplication by a reciprocal. And again, do not ever forget plus c. Every derivative has a plus 0, which came from some constant, which may be 0 also, I don't know, but we got to account for the possibility there is one, so we put the plus c there. All it's up to do now is to make our answer prettier. Fractional powers are perfectly fine with me for a final answer. If you want to go back to radical form, that's fine too. Take your pick. I'm going to leave it fractional power. So with that in mind, 7/9 x to 9/7, I can't make that any prettier, right? Okay, what about 5x negative 1 over negative 1?
Negative 5x.
Negative 5x and negative 1. How about negative 5 over x even? So the x to negative 1 moves to the bottom. The minus and the plus make the minus sign. The 5 just kind of hanging out. But the x negative first should be moved to the bottom. Negative powers and final answers, I'm not a big fan of that. Again, where we're going to be going with this is eventually we're going to be substituting values in for x. I'd rather substitute into 5 over x than 5x to the negative first. So just keep that in mind. Right here I got minus, of course, 2 times 2 is 4. We get x to the half power plus c. X to the half power is just the square root of x, which isn't very hard to do. But I like my answer to be consistent, so if I did a fractional power for the first one, keep a fractional power for the last one. I don't want to have this as a fractional power, this is a square root. So, and honestly, that's a fractional power, there's a root. It just, to me, that seems kind of not good math. So, be a little consistent in what you do. But anyway, that would be the final answer there. And again, that is the antiderivative of the function. If I differentiate this, I would get that. And again, you can verify if you wish anytime on these problems.